Hey everyone, and welcome. Today, we are going to dive into the awesome world of databases. You might be wondering, why do I need to learn about databases? Well, almost every app you use, from Instagram to your online banking, uses a database. Think about all the posts on Facebook, all the products on Amazon, or all the videos here on YouTube. All of that data needs to be stored somewhere safe, organized, and easy to find. That's where databases come in. They are the backbone of modern technology, and learning how to use them is a super valuable skill for any aspiring developer, data analyst, or tech enthusiast. In this tutorial, we're going to learn everything you need to get started. We won't just talk about theory, we're going to get our hands dirty and actually build stuff. I'm going to show you how to use SQL, which is the language we use to talk to databases. We'll be working with a specific database system called PostgreSQL, which is incredibly powerful, free, and used by huge companies all over the world. By the end of this, you'll understand how databases work, how to write basic SQL commands, and how to build your own simple database. It might sound like a lot, but I'll break it down step by step. We'll start from the very beginning. First, we'll cover the fundamental concepts, like what tables, rows, and columns are. Then I'll walk you through installing PostgreSQL on your computer, and we'll jump into writing SQL code to add, find, change, and delete data. We'll also look at how to connect different pieces of information together, which is one of the most powerful features of SQL. I designed this guide to be super clear and easy to follow, even if you have absolutely no experience with programming or databases. So grab a drink, get comfortable, and get ready to learn a skill that will open up a ton of new possibilities for you. It's going to be a lot of fun, and I promise to make it as simple as possible. The building blocks of data. Alright, so what exactly is this thing called SQL? SQL stands for Structured Query Language. That's a fancy way of saying it's the language we use to communicate with databases. If you want to ask a database a question, you use SQL. It's the standard language for managing data held in what's called a relational database. With SQL, you can store new information, retrieve existing information, make changes, or remove information you no longer need. It's a simple but incredibly powerful language. Okay, it's time to get our hands on the software. We're going to install PostgreSQL. It's one of the most advanced open-source relational databases in the world. It's completely free to use. I'll guide you through the install for Windows, Mac, and Linux. Start at the official PostgreSQL website. Go to postgresql.org and open the download section. You'll see installers and packages for your system. If you're on Windows, the process is super simple. The site points to an installer from etdemy. Download the latest Windows installer. Run it, and a setup wizard will pop up. It will ask where to install PostgreSQL, which components to include. Leave defaults, where to store the data, and to set a password for the Postgres user. Remember this password. For Mac users, you have a few options. Use postgres.app. Download and drag to applications. Open it and it starts a PostgreSQL server. Or use Homebrew. Brew install PostgreSQL. Homebrew handles download and setup for you. On Linux, use your distro package manager. Ubuntu, Debian, sudo apt update, then sudo apt install PostgreSQL contrib. Fedora CentOS, sudo dnf install PostgreSQL server, then initialize the database cluster and start the service. The installer creates a default Postgres user. You get two main tools, PSQL, command line, and pgadmin, graphical interface. Open your terminal and type PSQL Postgres. It will ask for the Postgres user's password. Enter it and you'll see a new PSQL prompt. You're connected. In pgadmin, add a new server connection. Give it a name like my local server. On the Connection tab, leave the host as localhost, set the user to Postgres, and enter the password you created. Now that we have PostgreSQL installed, let's learn how to connect to it and look around. The first tool we'll talk about is pgadmin. This is a graphical user interface. It gives you a visual way to see and manage your databases. Once connected, you'll see your server in the browser tree on the left. The other tool is PSQL, a command line interface. You interact by typing commands into a terminal. Inside your server, you can create multiple databases. Think of a database as a container for a specific project. For example, you might have one database for a blog, another for an e-commerce store, a third for a game. Create a database in pgadmin by right-clicking Databases. Create database. In PSQL, run, create database. My _new database. It's that simple. A new empty space for your project. Within each database, data is organized into schemas. A schema is like a folder that holds tables, functions, and other objects, views, indexes, etc. New databases get a default schema named public. For beginners and small projects, the public schema is usually enough. All tables you create go into public by default. As projects grow, you can add schemas, but for now, everything we build will live in public. Section 5. The core 4. Insert, select, update, delete. These are often called CRUD operations, which stands for create, read, update, delete. Let's imagine we have a students table with columns for student ID, name, and major. First up is insert. This command is used to add new rows of data into a table. Insert into students with name, major, values, John Smith and computer science as a new row. We can run this command multiple times to add more and more students to our table. Next, we have select. It's how we ask the database to show us the data. To see all the students, select all from students. The asterisk means all columns. To see only names, select name from students. We can also filter the results using a where clause, like major equals art. What if we need to change some information? That's where the update command comes in. The query would look like this. Update students set major equal sign biology, where name equal sign John Smith. The where clause here is super important. If you forget it, you will update the major for every single student. Always double check your where clause. Section 6. Connecting the dots. Table relationships and joins. Databases become truly powerful when we start connecting our tables together. One teacher can teach many courses. Each course is taught by one teacher. Our courses table would have a foreign key column, teacher_ID, that points to the primary key of the teacher's table. Sometimes the relationship is more complex, a many-to-many. A student can enroll in many courses, and a course can have many students. The solution is a third table, a join or bridge table. Call it enrollments with student_ID and course_ID. How do we get info from multiple tables? Use join and select. For example, select courses.name, teachers.name, from courses join teachers on courses.teacher, _ID equals sign teachers.id. This joins rows where IDs match and shows course name and teacher name. A join combines rows from tables based on related columns. That's how we retrieve combined data efficiently. Section 7. Making data faster and smarter, indexes and aggregates. As your tables grow to thousands or millions of rows, finding data can get slow. This is where indexes come in, like the index at the back of a book. An index is a special lookup table the database uses to find rows faster. If we often search by name, create an index on the name column. Primary keys are automatically indexed, which is why lookups by ID are so fast. SQL gives us powerful tools to summarize data. Count, counts rows, sum, adds values, AVG, computes averages, max, finds the largest, and min, finds the smallest. We make aggregates more powerful with group by. For example, select major count from students group by major. This groups students by major and counts how many are in each. Section 8. Mini project, a simple university database. We'll create students and courses tables and an enrollments table to handle the many-to-many relationship. Create table students. ID serial primary key, name varchar, 100. Major varchar, 100. Create table courses. ID serial primary key, name varchar, 100. Credits integer. Create table enrollments. Student_ID integer references students ID. Course_ID integer references courses ID. Primary key. Student_ID, course_ID. The references keyword creates the foreign key link and the composite primary key prevents duplicate enrollments. To list courses for a student like Alice, select courses.name from courses. Join enrollments on courses.id equals sign enrollments.course_ID where enrollments.student_ID equals sign 1. To list students in biology 101, select students.name from students. Join enrollments on students.id equals sign enrollments.student_ID where enrollments.course_ID equals sign 2. Section 9. Beyond the basics. Advanced PostgreSQL features. PostgreSQL allows you to store JSON data directly using JSON or JSONB. JSONB stores data in a more efficient binary format, making it faster to process. And you can query inside JSON using special operators, gives you the flexibility of a NoSQL database, while keeping the power and reliability of a relational database. Another critical concept is transactions, a sequence of operations as a single unit of work. If one operation fails, the entire transaction is rolled back. Acid, atomicity, consistency, isolation, durability. Transactions ensure both actions happen or neither. PostgreSQL supports stored procedures, functions, and triggers that run on events like insert, update, delete, for example, auto timestamp on update. Section 10. Your journey continues. What's next? We started with the basics, core commands, relationships and joins, indexes and aggregates, a mini project, and advanced features like JSON and transactions. Practice, practice, practice. Expand the mini project. Think of questions and write queries. Explore left-right joins, subqueries, and ORMs like Sclalchemy or Prisma. A solid foundation in SQL will serve your tech career. Keep learning, keep building, have fun.